In this problem, we're going to be finding the specific heat of the unknown material. Our problem is an unknown material weighs 626 grams and its initial temperature is 500 degrees Fahrenheit. The unknown material is then placed in 700 grams of water, which the initial temperature is at 34 degrees Celsius. If the final temperature is 52 degrees Celsius, what is the specific heat of the unknown material? First, we're going to go over the equations that are going to be needed in order to solve this problem. We have Q equals mc delta T. Q equals heat flow, m equals the mass, C is our specific heat, and delta T is the change in temperature. Final temperature minus the initial temperature. Another way of writing this that we're going to be used later on is C equals Q over m delta T. This one we're going to be finding the specific heat, so we're going to just change the C and the Q. The last equation that we're going to need for this one is to change our degrees Fahrenheit to degrees Celsius. So we're going to have C, which equals Celsius, equals 5 over 9 times Fahrenheit minus 32. These are just going to be the equations that we're going to need in order to solve this problem. So, what we're going to do now is we're going to convert our 262 grams and our 700 grams. Then we'll worry about the Fahrenheit after. To do that, we're going to do 1 gram over 0.001 kilograms times 1 over 626 grams. Grams cancel out, and what we're left is 0.626 kilograms. Then we're going to do our 700 grams. 1 gram, 0.001 kilogram times 1 over 700 grams. Again, grams cancel out, we're left with 0.7 kilograms. Now that we have converted our grams to kilograms, we can now take the degrees Celsius or the degrees Fahrenheit and change that to the Celsius. So for that, we're going to use our C equals 5 over 9 times 500 degrees minus 32. Simplified, we will have C equals 5 over 9 times 468. 5 over 9 times 468, that equals 260. Now, what we can do is we can make our little T chart, which will help us determine what we know and what we don't know. So for our T chart, we're going to do unknown. We're going to do our water. And for each one, we're going to do the M, C, delta T, M, C, delta T. For the water, we know that the mass is going to be 0.7 kilograms. Specific heat, we know for water is 4,180 joules per kilogram degrees Celsius. And for our temperature change, it's going to be 18 degrees Celsius. To find the temperature change for water, we know that our final temperature is 52 degrees Celsius minus our 34 degrees Celsius, which leaves us with our 18 degrees Celsius. Now that we know the temperature for the change in temperature, we're going to be able to finish our equation and solve for Q. Q equals M C 4180 joules per kilogram degrees Celsius times 18 degrees Celsius. Our units cancel out, and all we should be left with is our joules. Q is then equaling 52,668 joules. Now that that's done, we will be able to find C equals QML, or QM delta T. The unknown material, to finish this part so we could find out, we know that the unknown material initial is 0.626 kilograms. We don't know our specific heat, that's what we're finding. And the delta T we know is going to be negative 208. To find this one, what we're going to do is you're going to take your 52, the final temperature, minus our 260, which is the initial temperature, and that will get you your 208 degrees Celsius. Next, what we're going to do is we're going to be able to take all those and plug them into that equation. So we're going to have C equals Q over M delta T. So we still don't know specific heat, so we'll leave that as C, which equals our Q. But our Q is going to be negative, so it'll be negative 52,668 joules. Now we're going to know that we're going to take our mass for the M, which was 0.626 kilograms, and we're going to take the final temperature, which is negative 208 degrees Celsius. Simplified, what we should have is C equals negative 52,668 joules over negative 130.208 kilograms degrees Celsius. Solved, we will have our answer for the specific heat, which is C equals 404.49 joules per kilogram degrees Celsius. Then, now that we know all the information and we have found what C is, we now know that the specific heat of the unknown material is 404.49 joules per kilogram second. And this is exactly how to find the specific heat of an unknown material.